In this video, we're going to be talking about the nomenclature of alkanes. Alkanes are a series of organic compounds, and they are considered to be hydrocarbons. Hydrocarbons are compounds which contain only carbon and hydrogen. Now, alkanes are a series of compounds, or a family of compounds, that we generally call as a homologous series. So a homologous series, what is a homologous series? A homologous series is a group of organic compounds, mainly hydrocarbons, which have the same empirical formula but different molecular formulae. And these homologous series can be differentiated with each other by CH2. So the difference between one compound of a homologous series and the other compound is generally the presence or the absence of a CH2. And as I said, they have the same empirical formula. Let's just note down here. Now that we've established what a homologous series is, let's get into naming the alkanes. Now, our alkanes are considered to be saturated hydrocarbons, saturated HCs, and the names of alkanes end with the suffix -ane. And the prefix of alkanes is determined according to the number of carbons which are present in the compounds. So the lowest number of carbons we can have in any compound is 1, and this has the prefix meth. And then we have compounds with a carbon number of 2, and they have a prefix of eth. Then compounds with 3 carbons have the prefix prop. Those with 4 carbons have the prefix bute. Then moving on to 5 carbon compounds, they're named starting with pent. When we move on to 6 carbon compounds, we use the suffix hex. In 7 carbon compounds, we use the prefix, hept. In 8, the prefix is oct. In 9, it's non. And then in 10, we have dec as the prefix. So now we have this list of prefixes over here, and they're then paired with the suffix -ane to give us the name of our alkane. So the simplest alkane that we can have would then be, let me just draw it here. So the simplest alkane would be with 1 carbon. Now, as I said before, alkanes are hydrocarbons, so that means the carbon is bonded to hydrogen. And as we know, a carbon can only make 4 bonds. And this relates back to why they're called saturated hydrocarbons as well, because a saturated bond is when the element is bonded to the maximum number of bonds that it can have. So the maximum number of bonds that a carbon can make is 4. In hydrocarbons, particularly in alkanes, the carbons have 4 bonds each, so we call them saturated hydrocarbons. So now this here is our methane. It is just 1 carbon bonded to 4 hydrogens. So if we move on to ethane, it's 2 carbons bonded to each other, and then the other 3 bonds are with hydrogen. So let me just fill out the hydrogens here. And then if we move on to propane, so this, forgot to label it, ethane. And then if we move on down here to propane, same thing as before, we have the parent chain to be 3 carbon molecules, and each of those carbon molecules then makes bonds with hydrogen. If we were to draw butane, it would be a parent chain of 4 carbon atoms, and then each carbon atom, the rest of the bonds are with hydrogens. Right, now you may have picked up on the fact that I'm using the term parent chain. So what is a parent chain in an alkane? So a parent chain is the longest continuous chain of carbons which is present in the hydrocarbon. And this parent chain is where our name comes from. So when we are considering naming alkanes, this is our first rule. So we have to consider the longest continuous chain of carbons that are bonded to each other as for our parent chain. So let's just note this down to be rule number 1, right? Let's put our rules of naming up here. And so just to reiterate, when we're naming alkanes, or as a matter of fact, if we're naming any hydrocarbons, when the first step is always to look for the parent chain. So you have to identify the parent chain. This is where your prefix comes from. So the prefix, how do you decide which prefix to use? It's from the parent chain, right? So then moving on. Now the simplest alkanes are those which are without any branches, without any side chains, and we can name them very easily using our list of prefixes. But what happens if in an alkane you have branches or you have side chains? So let's consider this compound over here. And let's see how we would name this compound. As we can see, the first step over here would be to identify the parent chain. So let me look for the longest continuous chain of carbon atoms. I can see over here, this is carbon number 1, number 2, number 3, number 4, and number 5. Just to check with this one, right here, it would be 1, 2, 3, 4, and 5. So either way, the longest continuous chain in this molecule is 5 carbons. Right. So what about this side part that we can see? Now, any side chain that appears in our hydrocarbon molecule can be called as a substituent. And there are certain rules that we have to consider when naming these substituents. So now, over here in this branch, we only have 1 carbon. So this would be our methyl group. The prefixes remain the same. We're only changing the suffix from -ane to -yl. So for example, if we have a branch of 2 carbons, it would be ethyl, and so on and so forth. Now over here, as we mentioned before, our longest parent chain is with 5 carbons. So we're using the prefix pent. Right, let's just jot the name down here. So pentane. And then we have to identify on which carbon is the side chain. Now, I could either do it this way. This could be carbon 1, 2, 3, 4. Or I could do it this way. So 1, 2, 3, 4, 5. Which one is the acceptable way? So the acceptable way of naming side chains is for our side chain to have the lowest possible number, which in our case is 2. So 2-methyl pentane. Let's look at another example in which we have maybe multiple side chains. So now let's consider this molecule over here and how we would name it. Now over here, let's identify the longest running chain of carbon atoms, which in our case seems to be 1, 2, 3, 4, 5, 6. Let's just check if there is anything else. For example, if we go down here, that would only give me 5, so that can't be possible. So our parent chain here has 6 carbon atoms. So the prefix we are using is hexane. And then over here we have 2 side chains. We have one here and we have one here. And both of them have only 1 carbon atom each. So they're methyl groups. And then when we have the same group, which is occurring twice, we have to indicate the number. Now we have to see which order gives us the lowest possible arrangement. So if I consider it this way, it would be 3, 5. But if we consider it this way, it would be 1, 2, 3, 4, 5, 6. So if I use the numbers at the top, if I name it according to this, if I number the carbons according to this, my side chain methyl groups are falling on 2, 4 dimethyl hexane. So the di indicates that there are 2 methyl groups, and where are the 2 methyl groups? That is indicated by the numbers. Alternatively, you might be tempted, or you might mistakenly write the numbers as 3, 5. That would be incorrect because you have another combination which gives you a lower number for the side chains. So you always have to go with the lowest number possible for the side chains, and we can add that to our rules up here. So the first one was, we said that it was to identify the parent chain, and then the second one was to give the lowest possible numbers. Right, now let's move on to more examples. Now let's look at this molecule over here. If you want to take a second to try and figure it out on your own to see if you can name it, please feel free to pause the video, and you can come back when you think you have a solution and see if it matches with the one that I present. So now let's start with identifying the longest continuous chain of carbons. I can see here number 1, number 2, number 3, number 4, and number 5. So that gives me 5 carbons. So that gives me pentane. And then if I go towards my side groups, so I have a branching here, I have another branch here, and I have another branch down here. Now in the branch down here, we have 2 carbon atoms. And these 2 carbon atoms, the prefix that we're going to be using is ETH, and the suffix is YL, so that gives me ethyl. Whenever we have a branch with 2 carbon atoms, we name it ethyl. So that's C2H5, that's the branch, and that's ethyl. Now over here, let's identify the position of our side groups. So we have a methyl group on the second carbon, we have a methyl group on the fourth carbon, and we have an ethyl group on the third one. So we have 2 different side groups starting with 2 different alphabets. So when we're presented with a scenario in which we have 2 different side groups, we name the side groups according to alphabetical order. So according to alphabetical order, we would start with the ethyl group, so 3 ethyl, and then in between an alphabet and a number, we put a dash, and then 2, 4, and remember that we have 2 methyl groups, so it would be dimethyl pentane. Now there seems to be a space here, but when you're actually writing the names, we write them without any spacing. So let me just clarify that. So the name is then 3-ethyl, 2,4-dimethyl pentane. Now, an understandable point of confusion at this point is that if we're considering alphabetical order, why did we write ethyl before dimethyl pentane? And the answer to that is that when we are naming multiple substituents and we have different substituents and we want to consider alphabetical order, we consider the name of the substituent. We don't take into consideration the prefixes di or tri, because we're not naming the position of those substituents, we're naming the actual substituents according to alphabetical order. Let's consider a different type of alkanes. So far we've been looking at alkanes which are in straight chains or in branched chains. Now let's talk about alkanes that are in cyclic form. Over here we can see a cyclic alkane, and this alkane has 3 carbons. So let's just start by jotting down the prefix propane, and then because it's cyclic, it would be cyclopropane. So cyclic alkanes, naming them is simple. We just consider the same rules that we've been considering so far in naming alkanes, except that we have to add the prefix cyclo to indicate that it is not a straight chain alkane. So how is it possible for us to identify if we're looking at a cycloalkane or if we're looking at an alkane just by looking at the general formula? So alkanes have the general formula of CnH2n plus 2. And all alkanes conform to this formula. So for example, if we think of methane, the formula for methane is CH4. The formula for ethane is C2H6. And for propane, we have C3H8, and so on and so forth. However, for cycloalkanes, the general formula is CnH2n. And this is the major differentiating factor between cycloalkanes and alkanes apart from their structure. Throughout the video, we discussed different rules about naming alkanes. We discussed different types of substituents that may be present on our alkanes, and I showed you various examples that might be useful. And you can always refer back to these examples in this video to consider the rules if you're ever stuck with a problem about naming alkanes. Thank you for listening to this video, and I hope you found this tutorial helpful.